We're going to be talking about permeable pavement design and maintenance, municipal lessons and observations. We have three presenters today. Mark Palmer from the City of Puyallup, Jessica Knickerbocker from the City of Tacoma, Tim Horton from Skillings, Connolly, and we also have a panelist, Keith Muhich from Miles Sand and Gravel. So with that, we're going to start with Jessica's presentation.
Good morning. So why build sustainable roads? Well, in Tacoma, we have about a third of our city that discharges into fresh creeks. So those are one of our top priorities for reducing flows and providing water quality. Also, I know that we're not alone in having several of our roads failing, but in Tacoma, we have a pavement index that's well below a city of our pavement index well below average for a city of our size. So how do we do that? I'm going to talk a little bit about green roads and how that can help us meet that criteria and to rebuild our roads in a way that is cost-effective, good for the environment, and most importantly, something that we can actually maintain. So Green Roads is a sustainability ranking system for roads. It is similar to LEED, and it applies to all roadway projects from a very small project to large ones. Just to give you an idea, because there's a lot of misconception that green roads is actually green infrastructure. I'm not going to lie, that's how I got into it. But as you can see by this little pie chart, the green one is the environment and water section, and only about 10% of that 19% is stormwater related. So it really looks at the whole carbon footprint of your road and how you construct your facilities. So what are the benefits that we've seen in Tacoma? One is that we have a number of high-level planning documents that we're supposed to use to design our roads, and this helps to put it all down into a simple checklist that actually speaks engineer. It also inspires interdepartmental communication and results in more efficient projects. And as you can see by this picture, it also provides a higher level of recognition for your projects. This is my director throwing the opening pitch for Rainier's game. So we have 4 green roads that also have green infrastructure throughout them, and I will be going into a little bit more detail on all these projects. So our first project, the Cheney Stadium Sustainable Stormwater Project, was a 2-phase project. The first phase was Clay Huntington Way, which is up to your left there off of 19th Street. It was our first installation of Pervious Asphalt roadway. All of the areas in blue are Pervious Asphalt. The second phase, actually, we received a grant from the Department of Ecology, which is this larger section here down at the bottom. So we manage about 11 acres of commercial area. Okay, sorry. We manage about 11 acres within only 4 acres of Pervious Asphalt. We have, the phase 1 has been installed for 3 winters now, and it's exceeding all expectations as far as the modeling that we've shown. It's only actually overflowed at one point in time when we had a really large storm event, but that middle area right there was, it has about 5 acres that all contributes to 1, and it was modeled to infiltrate only at 85%. So. I'd like to also point out that this approach was particularly in Clay Huntington Way, the roadway, it was about half the cost of traditional improvements. But that didn't come without some very valuable lessons that we've learned. So as I said, this was our first project, and so we used the LID manual as some guidance, and ultimately when it came down to it, our contractor did just about everything that you're not supposed to do in the LID manual. They excavated the whole road down to native subgrade. They used it as their haul road. They put their stockpiles on top of it. They wanted to use the rain garden as erosion control. Just about everything that you're not supposed to do. And plus we were doing it in the wintertime because of course it's at a baseball season and it's the only time you have available to do that. Ultimately, couple things that we learned from that. One was that you need to have a performance element in your spec requiring the infiltration rate still be maintained. And the other one was, we worked really closely with our geotechnical expert that was on this project, and they helped us to scarify those subgrades and get them back to what they were originally supposed to infiltrate at. A couple other things that we learned about this, you can see it, where the sweeper truck is at. There was an area where we had with a bird bath. There was an issue with our hub contractor, and that they couldn't quite get the curb right. They actually installed it. They took 4 cracks at it, and finally we left a small area that was a bird bath. But that was the area where we ended up with some ponding. So, it was primarily because of the run-on from just the sidewalk here, and that first summer, or that first area where the concrete cures and there's the little fine particles that come off of it, plugged it up pretty quickly. So if you have an area that you have run-on, it's not necessarily a done deal, but you definitely have to maintain it right up front a little bit more heavily than other areas. The second phase of our project, we ran across some issues with the permeable ballast. WashDOT actually got involved in this project, and when we were out there inspecting it, they came out and looked at it, and they asked me the question, how are you testing this rock to make sure that as it's exposed to water for the life of it, that it's not going to degrade? And I was like, well, we used the LID manual that said to use your permeable ballast spec. And they said, well, the testing that we do on that rock and the requirements that we have does not have anything to do with how water is exposed to the rock, because we don't expose our subgrade to rock, or our base material. So we went back and looked at it a little further. We also had an ASA cert on this project for this rock, but the rock was degrading actually as it was being placed. So we actually had to remove it all. And in the future, we will be testing the rock at the pit before it comes on site. And we also are changing the specifications to increase the LA abrasion and degradation testing requirements above what WashDOT spec is. Our Alaska Street project is an arterial that has pervious concrete in the parking lanes and some of the sidewalks. This project was a little bit different in that we extended the permeable ballast underneath the sidewalk and put in standard concrete on top of the sidewalk, or standard concrete on top of the ballast. And the ballast extends 2 feet onto the past the sidewalk to catch that run-on from the residential properties. That was a recommendation from our geotech to minimize the impact on the residents. It looks exactly like standard concrete. Well, it is standard concrete. Looks just like every other street, but it has a pretty big impact on stormwater. It also doesn't get into the question of, does the sidewalk then become a stormwater asset rather than maintained by the residents? So that's one reason, another reason why we went with this route. We had one area of the road that had a steeper section. It was about 7%, and our roadway engineers, they went really out on a limb to allow us to put this in the parking area. But they were not excited about the check dams. They were very, very worried about those. So instead, we installed overflow pipes, perforated pipes that were tipped up, and those have been working very well. Oh, wrong way. So we have had our issues with this project. One of them is that when standard HMA is first placed, those first 2 or 3 years in the summertime, there's fine particles that come off of the asphalt, and it goes normally into our storm sewer system. It doesn't get treated, but conveniently we had pervious concrete here that plugged it up pretty quickly. We got a call from Bellingham. They've had similar situations with this, but after about 3 years, that has subsided, and they now they don't have that issue as much anymore. So we're watching that. We're sweeping it more frequently than we normally would, but we expect that to dissipate. We're also looking at potentially a retrofit for this. Another issue is that we designed this with the standard turning radius for our sweeper trucks, but the sweeper truck radius is really for the whole sweeper and the brushes that go out and around, and the vacuum part is only under the wheel wells. So those corners never actually get vacuumed. So definitely something to consider if you're looking at putting it in a parking lane. We also learned that gutters are a bad thing, and they convey all the stormwater from the driveways just like they're supposed to, and they pop it out right where you turn the gutter from lip up to lip down, and that's where your plume of sediment is going to go. So we aren't going to be putting gutters in our future projects. And if we do have to put a gutter in, we'll be putting in these overflow infiltration galleries to help have that sediment go and collect in those areas where we want, and we can maintain them easier and preserve the function of the road. Wapato Lake Drive was one of our first public pervious asphalt roadways. This was a grant from the Department of Ecology. It was the full roadway, 1,300 lineal feet. We designed this to a 40-year design life with a thicker cross-section. And this was also half the cost of the traditional design approach. This was a 1,300 lineal foot road, and it had 2 catch basins right in the middle. Guess where the road failed? Right in the middle, right? So we did not extend storm to have a catch basin every 350 feet. We left it as it was with the catch basins in the middle for the emergency overflow. This again, back to the curb and gutter. I want to hammer this home a little bit more. And anyway, there's not a whole lot of information that I have found about curb and gutter as it relates to designing pervious roads. But every single project that we have, this has been a real issue with my contractor, construction management, and our inspectors. They are very worried about putting curb on top of permeable ballast and what that will look like, if they're going to get compaction underneath of it. So really think about what it is that you're going to be putting that curb and gutter on. And if you talk to experienced contractors, it's not a big deal. But if they haven't done it before, you're definitely going to have to stick to your guns on that one. A couple other key features on this is the turnaround at the end of the street was little substandards. It was right next to a lake and a wetland, so we had to work closely with our traffic department to get it reduced. And we did that with standard HMA. Groundwater, of course, is a very important consideration for your pervious projects. And we had 3 groundwater monitoring wells for both of these projects. And in addition to that, we put in a monitoring port within the pavement itself, so you can see actually if there's any ponding within that area. This was really helpful when we had the wettest season on record last year, and our residents complained that my pervious road was flooding out their backyards. And we were able to take them right out in front of the street and show that there was no water actually in that, in the roadway. So what is wrong with this picture? Anybody? This is actually from 2009, where the city of Chicago installed one of their first applications of pervious concrete with an asphalt paving machine. So it just goes to show that this industry is changing at a pretty rapid rate, and you really need to have a core team of engineering, civil engineering, geotechnical, materials engineers, and your inspection and maintenance staff to have these successful in your city. Green infrastructure has been demonstrated to be a very cost-effective strategy for maintaining stormwater and rebuilding our roads. And it requires a hands-on team with a hands-on approach with a knowledgeable team. And of course, we definitely need industry standards. And that's where Tim is going to explain our regional group that's been working on these specifications.
Thank you. So, as Jessica said, we're working towards some standard specifications, and that's kind of what I'm here to talk about. And this kind of developed out of both Mark and Jessica's work and through industry as well. Each city, county was putting out their own set of specifications. And while that's not necessarily any specification was wrong, what was happening is industry would get a pervious paving contract, but the city of Tacoma would be different from the city of Puyallup, which would be different from King County. And so much like WashDOT has done with the traditional HMA, if we can get the same aggregates together, then they can make it in larger quantities and reduce cost. There are some other issues with those job mixes that were coming out. Some of them only certain plants could produce. And so our goal with this particular specification is to make something that can be used in Washington over and over again. And so as for the standard specification, our goal is to improve the bidability, so each contract can be bid by multiple contractors. We want to reduce unintended consequences. For example, one mix design allowed 0 fines. which on a paving, for the pavement itself isn't an issue, but as industry went through to try and create that, those fines helped cool their equipment. And when there were no fines in the mix, their equipment would overheat and it caused them to not be able to produce the asphalt at the ideal temperature for laydown, which then would impact the durability. So the next thing we're trying to do with the spec is improve performance. I know most of you have probably heard the horror stories about you lay it down and the next day someone turns their wheel and there's a big hole in it. And so the city of Puyallup has been working on increasing the compaction requirements and increasing vibratory compaction to try and improve durability. There's a balance with that because the more compaction and the denser the mix gets, the less permeability you have. And so we're working together through testing, additional testing, to try and come up with something that works better to increase that durability so we can expect a similar life from our porous HMA that we do from our traditional HMA. And then the last thing we're trying to accomplish with these specifications is to facilitate discussions. So our group includes many cities, counties, other design consultants, and industry, all giving input into the specification. And at the end of the day, our goal is to be able to produce something that everyone can agree with and we can use in our project. Thank you.
I'm Mark Palmer, city engineer for the city of Puyallup, and love seeing all of you here. Would like to express my appreciation again once more for Joy, Craig, Tanya Lee for putting this event together. This is remarkable to get everybody here to talk about stormwater. I'm going to talk just briefly about a few things, some of the observations and some of the lessons learned we've had on some of the city of Puyallup's projects. One of the things I just want to kind of review, I've kind of come up with these design performance goals that we have with permeable pavement. Some are pretty obvious, but the one that kind of has been the sticking point, as was just mentioned by Tim, was the trying to get a durable, long-lasting pavement. We're fighting that balance of trying to keep the porous pavement porous, but also get it durable so we don't have wearing or raveling or those issues. So those are some of the things we've really been trying to work on hard here with the specification and some of the things we're doing with porous asphalt. I just did this as a brief consideration, and Keith will probably be able to express some of this on porous asphalt, pervious concrete have some differences, and when you're doing your designs and you want to consider using these on your projects and wherever you're doing them, you may want to take it into consideration. Right now, obviously, porous asphalt doesn't require a certified installer. As long as the plant can get the mix design to the installer, any installer can put it in. That's obviously opposite of pervious concrete. Pervious concrete is going to require your certified installers. It's very important to have that since that's a very different and distinct process for putting pervious concrete down. As was mentioned, we don't have a lot of plants regularly making porous asphalt, so basically porous asphalt does have the disadvantage. You can't get it in small batches. I've had many people come up to me wanting to put in porous asphalt driveways, and I have to kind of tell them if you don't have a bunch of yardage in there or tonnage to do that, you really probably aren't going to be able to do that at this time in the future. Hopefully that will change. As Jessica's already mentioned, it can be cost effective on both of these for porous asphalt and porous concrete once you take into consideration the stormwater infrastructure, the water quality features that you would have to put in, and quite frankly the land that you would have to take up to install your stormwater features that would be there if you didn't use porous pavement. Porous asphalt does have the advantage of being able to be used almost immediately, and I bring that point up because we are preparing to do 39th Avenue Southwest in the city of Puyallup as a pervious concrete road. And 39th Avenue Southwest, if you're familiar with it in the city of Puyallup, is a busy arterial. It's where our Costco is located, and you all are probably familiar with the traffic that a Costco generates. So it's really not an option for us to close down that main arterial for 7 days while that concrete cures. So we're looking at different alternatives there. Asphalt would be a possible solution up there. But again, then you get to the next point. Porous asphalt is going to be much more sensitive to soil conditions when you're talking about flexible pavement design and the high volumes that are on arterial roads. If you start looking at what WashDOT recommends for a pavement section for porous asphalt and you get on arterials, the roadway section will get pretty thick, and that can get you into other conflicts with your existing utilities in the road, and just the excavation costs can start making that a little less cost effective. So basically on a life cycle cost and even an initial cost, pervious concrete tends to start getting to the advantage on arterial roads, which is why the city of Puyallup on arterials will be looking at pervious concrete on the 3 projects we've got going instead of porous asphalt. Just kind of looking, if you're using porous asphalt, I'm going to jump around. This is a lot of design and lessons learned stuff on other projects. If you are using a choker course, and I know we should get into some of that discussion in the question and answer period on alternatives to choker courses for porous asphalt. Porous asphalt, you need to have a choker course only because you're trying to get a working surface for your paving machines out there. You don't want to be trying to work on that large diameter aggregate out there. That's rough to work on. However, if you don't get the aggregate right, you could end up with the situation you see in the picture on here on the next one, where you end up having a lot of rutting. That's basically what happened with that specific aggregate, because I had too much aggregate of one size in there, which allowed for a lot of rutting. It's relatively easy fix. Just get a little bit more of a better graded mix, and you can get that so you can have traffic on it and pave on it. One of the things that my lesson learned on that was get the chart out and look at map your specifications on your chart and look at where your aggregate falls in there. And this is a bit difficult to follow on this one, but the choker course specifications are the 2 sets of green lines, so your aggregate should have been falling in between there. The red line is the one that I had actually mistakenly accepted, and you can see how far out that falls outside the specification. If I had done this graph, I would have never accepted that on that particular project. The substitute one was slightly larger aggregate in size, but it did follow the shape of the curve fairly effectively. In the lower end, it was within the specification, and it was well graded enough that it actually bound up and was a good supporting surface for the paving machines. Mentioned that porous asphalt. This is one thing. What you're looking at here is a cross section for our WSU Phase 1 LID project, which we're hopefully applying for. There's probably DOE grant managers out here, but applying for a DOE grant tomorrow on this. This particular one is an arterial, but we are going to be going porous asphalt on this project. And the reason we're going to porous asphalt is because we've got about a 4 or 5 foot layer of peat that's underneath, about 10 to 15 feet down on this one, and we don't want to be putting a rigid pavement on top of this very flexible and differentially moving soil. So we're going to be putting porous asphalt on here. But again, we talked about section thickness. If we're going to have a lot of traffic, have poor soil conditions, and a flexible pavement design, that could create a pavement section that could be 2, 2.5, even 3 feet thick. So one of the things we're going to be doing is putting a geogrid layer in here, probably in the upper 2/3 of the reservoir course, in order to spread that loading out and help us thin down the section. We're also going to use that innovative surface for putting the asphalt paving machines on. Jessica usually uses the porous asphalt treated base instead of a choker course on there, so the paving machines could work on it, but it also will add some structural strength to the porous pavement section as well. So those are a couple things you can take into consideration when you get into poor soil conditions and you need to use porous asphalt in those conditions. You can't use a pervious concrete on an arterial type road. One of the things on this is a picture of the 8th Avenue project. Jessica already kind of touched on this, so I won't hit on too hard, but do you need to have edge constraints? That's a question we did ask ourselves when we were designing it. At the point we did this one, we felt we did, but we used a flush curb. It's a 18-inch deep, 12-inch wide flush curb on this particular case. And that's worked well in this particular instance with the 8th Avenue project. If you do use curbing, I would recommend, as Jessica said, not to use a curb and gutter. Use a vertical barrier curb instead of a curb and gutter and just pave up to that. One of the other things we wanted to look at, do you need crowns? Typically the crown for roads in the city of Puyallup is 3%. We obviously felt we didn't need that, but we wanted to have some backup in case there was any clogging or any failure of the pavement. So there's a 1% crown on this road that will drain off into the rain gardens that are adjacent to the roadway section if there should be some failure on there. So keeping that into consideration. When you're doing your designs, if you're doing parking lots or large flat areas, keep in mind you have that freedom of actually grading your site flat. You don't have to put all the 0.5% dips and breaks and stuff that takes you hours and hours to design on a parking lot project. If you have porous pavement, you can flatten that out quite a bit, but you probably should have some grade in order that it drains positively somewhere. Wilson Loop, so again, we wanted to, thank you. we wanted to take into consideration that do we need to have that edge restraint or not. So on Wilson Loop and 6th Avenue Southwest, both of those projects, we actually just used our porous shoulder rock on that and butted that up against the pavement. And in both those neighborhoods, the neighbors are driving across that edge. They're on it parking all the time, and we've seen no degradation to the edge on that. But again, we do have a good firm, what's a good mix of rock, if I can get to that. Basically, we're doing a in-house mix of that. It's a number 57 rock being mixed with regular cross-surface base course washed out specification. Between the two, we get a good mix of voids on that, but it's also got enough fines that it really packs down and is resistant to rutting. So that's worked out really well for us on some of our applications within the city for porous shoulder applications. Construction points, and we've talked about compaction, so this is one of the things we want to talk about is make sure you get out there and get on the pavement during its compaction range. That'll be a part of your mix design. Make sure you're on it not before, not after. Get out there and mix it. And vibratory compact it. I was looking at some of the data that Jessica had done on her projects, which is shown here on nuclear density testing. Did the similar thing on the city of Puyallup. Then I decided to, since we had some other data, and I haven't thought this through, so if there's some big flaws in this reasoning, just jump out and grab me, because I just, 10 o'clock last night, I said, aha. Air voids versus percentage compaction, that's a direct calculation. I mean, they're obviously, to get your percent compaction, it's a matter of how much voids there are. Since our specification is saying we want to get to between 16 and 22% voids in our finished product, that kind of infers we need to be in the 80 to 85% range of compaction on our pavement. So once you go out to the field and you know what your RICE is or your maximum density of your design mix, you can calculate what density range you should be in for your project. You should be able to have your inspectors go out there and follow them with a nuclear densometer, get those specifications and know if you're in range for your compaction, and have them continue to hit it with the vibratory compactor until you get to that 80 to 85% range. Again, that's that balance, and I would tend to err towards the 85 range myself, because again, we want to keep that pavement durable, and I don't think we're going to have too much problem with the leaking. It's going to leak like it should in that void range. I think we have more of an issue if we are getting in the higher end of that range and having less compaction. We're going to have more rattling and more durability issues with the porous pavement. The more we can treat this like a conventional HMA pavement, the better off we're going to be. And just a couple notes that have been going to question and answers. Again, so in post-construction, you need to make sure you have regulations out there to make sure that the porous pavement stays in place. This is a formerly porous asphalt driveway in Puyallup that on the third or fourth owner after it was completed decided that the salesman that was telling him about seal coating was a wonderful idea, and he seal coated this driveway. So it's no longer porous, unfortunately. It was working very well. So one of the things you may want to consider, and this is on a project in the city of Tumwater, just put up little signs explaining that this is a stormwater maintenance facility in and of itself. Please don't dump materials here, and other considerations. Again, that's very simple and straightforward, but you need to make sure people understand that this is not a standard pavement. Please don't put your landscaping materials on here. Don't be doing other things to that surface. Maintenance, it's already been talked about. Sweeping regularly is just the regular maintenance on these things. Again, we have all these other issues, and these would be good discussion points and questions. Love to hear some questions on these as far as how you're going to handle building plats when you build all the roads, and then you have the home builders come in. That's always an issue. Utility cuts, and then after you've done your pavement, how are you going to handle those? And would love to hear all those questions. But I think I'm about out of time, so I'm going to quit, and we'll go to the questions. Thank you.